So we have a person that stands on a scale in an elevator, classic physics problem. As the elevator starts, the scale has a constant reading of 591 pounds. As the elevator stops, the scale reading is 391. No, sorry, newtons. Both there was 591 newtons and 391 newtons. So we want to assume the magnitude of the acceleration is the same during starting and stopping. And we want to determine the weight of the person, the person's mass, and the acceleration of the elevator. Okay, so we have two cases here. I've just illustrated schematically. This is when the person is accelerating up, and this is when they're accelerating down. In the first case, we do a force balance in the vertical direction. Well, in both cases, we do a force balance in the vertical direction. And we see in this case, we get N1 minus mg equals ma. In this case, we get N2 minus mg equals minus ma. And we know what M1 and M2 are. So what we can do here is basically just, we don't know what A is. We know G, we don't know M. But if we add these two equations, we can see that we just get N1 plus N2 equals 2mg. So basically that says that the person's weight is half of, or is the average of what these two readings were. And that is then 491 newtons. So that's their weight in newtons. Again, you probably could have figured out just to begin with, because these accelerations were equal and opposite in direction, that the weight would be the average of the two readings. Now, to get their mass, we just divide the weight by gravity, and that turns out to be 50.1 kilograms. To get the acceleration of the elevator, we can just go back to one of these equations, because now we know everything in each of these equations except for A. So I just went back to this equation, solved for A, plugged in the numbers, and we get 2 meters per second squared. So it started off with accelerating 2 meters per second squared, and it decelerated, or had a negative acceleration of minus 2 meters per second squared when it was slowing down.